You can write in a bit. You can write in that and then complete it. You can write in a bit.
In mains, how many questions will be having?
Means 20 questions in each paper.
Each paper. So time period, sir?
Yes.
2 questions for 1.5 hours.
2 questions for
1 hour. We are right.
you have that's what you have to increase over the
How to write it? So because the questions are lengthy, you have to cover all the 360-degree angle, right? So
that is where you have to use the words like how we'll discuss in class.
like if you read short, but will they understand, sir? Like say for example, diverging. If you read earthquake, volcanoes, like should we read volcanoes eruption will take place, earthquake will take place, like this, or we should only read earthquake, volcanoes and something like this?
No, you have to write certain sentences. You have to write certain thing. You can explain through diagram also. Certain thing you have to write, but sentence formation need to be there because you're writing answers. Either you write point wise or you write paragraph wise, but sentence formation need to be there. So we'll discuss, okay, how to achieve that in words, because 200 words or 150 words is what you are getting in the case of examinations. Either 150 in 150 words you have to write an answer, or in 200 words you have to write an answer.
So first question 250 words, what can we write in this, sir?
Which one?
The first question.
We'll discuss tomorrow. Okay, let me complete. So, okay, we'll discuss mains part tomorrow. Once in the break, we'll complete. Then we'll discuss the prelims part. No, total you have GS1, GS2, GS3, GS4. All 4 paper carry 250 marks each. So total 4 paper is 1000 marks.
GS1, there will be an option questions or there is 5%.
No such issue. Yeah, only 250 marks. You have to attempt that particular thing. Compulsory all questions are compulsory. Options are not. So in the last class, we have discussed concepts of lakes, we have covered concept of plateaus, and we started with the concept of atmosphere. Fine. So which is the largest lake in Australia? Which is the largest lake in Australia? Largest lake in Australia? Lake Erie. Lake Erie is the largest lake in Australia. Which is the largest lake in South America?
Lake Titicaca.
Titicaca, which is the largest lake in Africa.
Lake Victoria.
Victoria, fine. Which is the largest lake in, which is the largest continental lake? Which is the largest continental lake in the world?
Lake Bani.
Superior.
Lake Superior, yes, okay. So Lake Superior is the largest continental lake in the world. We discussed which is the lake which is largest in one country. No, Superior is not largest, yeah, it is Michigan. Superior shares boundaries between US and Canada. So largest in one country is what? Michigan.
Sir, is there any text to remember this lake?
Which one?
This lakes, sir.
Tricks, like you can form your own mnemonics. I will tell you after the class how to form mnemonics. So you can form your mnemonics and remember things like that. Right? Anything big, anything that is okay, bigger or something that is coming, you can form a mnemonics and remember. Like we discussed, okay, Russia in that, okay, what will happen? Lake Baikal lies. Lake Baikal is which lake? It is something like the deepest lake. So Lake Baikal is which type of lake? Deepest lake. So you have to, okay, you can form your mnemonics and okay, remember that. Clear? So either you can take first word or you can take some of the words and form some sentences to remember like that. So you can okay, form your own mnemonics to remember that particular thing. Fine? So remember that Lake Titicaca is what? Lake Titicaca is largest in case of America, South America. The continental lake, if question is asking which is the largest continental lake, Lake Superior. Then we also discussed which is the largest lake in Antarctica. Antarctica, which is the largest lake? Vostok. Lake Vostok is the largest in Antarctica. Fine. So these are the lakes we have covered regarding the world. And then we shifted to the concept of plateaus. How the plateaus are being formed on the basis of formation. How the plateaus are being formed.
Due to tectonic movement.
Yeah. One is tectonic movement. Then plateaus are also formed due to thermal metamorphosis. We discussed one is okay, thermal metamorphosis. Second is what? Tectonic movement, and third is what? Volcanic eruption. So there were three ways in which plateaus are being formed. So thermal metamorphosis, tectonic movement, and volcanic eruption. So thermal metamorphosis, we discussed what is formed, what is example. What is example of thermal metamorphosis plateau? Ethiopian highland. And we also discussed the massive central. Massive central is also an example of the thermal metamorphosis. Fine. What is an example of volcanic plateau? Deccan plateau. Yes. What is an example of tectonic plateau? Tibetan plateau. Yes. So those are what? Those are different type of plateaus that you are finding based on formation, based on the location. Plateaus can be classified into, based on location, plateaus can be classified into intermountain plateau and continental plateaus. Yes, okay, so that classification we discussed with regard to plateaus. Fine. We discussed certain important plateaus of the world. For example, which plateau is known as a mineral stone? Which plateau is known? Mexican plateau. Yes, Mexican plateau is known as a mineral stone. Which plateau is known for grape cultivations? Which plateaus is known for grape cultivations?
In China,
Massive Central. Yes, okay. It lies in France. Massive Central is known for what? Known for grape cultivation. Which plateau is famous for artesian well? Which plateau is famous for artesian well? Artesian well. Colorado Plateau. So Colorado Plateau, as we discussed, what is artesian well? Artesian well is when positive pressure and water starts to come out from the underground onto the surface. So it is famous for, Colorado Plateau is famous for artesian well. Fine. Which plateau is known for the diamond mining? Which plateau is known for, famous for diamond mining? Yes, Australia. Which plateau? Kimberley Plateau. And which is known for copper production? which is known for copper production, Katanga Plateau, which lies in the Congo. Katanga Plateau, which lies in Congo. Fine. So these are important plateaus that you have to keep in mind. So we discussed, there is one plateau which also discussed lies in the ocean, Indian Ocean. Which plateau they have discussed? Which plateau lies in the ocean, Indian Ocean region, between Seychelles and Mauritius? Mascarene Plateau, yes, okay. So we discussed Mascarene Plateau lies between Seychelles and Mauritius. That is okay, lying in Indian Ocean region. Fine. So those plateaus we have covered. Finally, we started with the concept of atmosphere, and we discussed the concept of what? Concept of the weather, concept of climate, and what is atmosphere. So we discussed atmosphere is what? It is an envelope of gases surrounding the earth, and how this atmosphere has formed? How this atmosphere has formed? Through outgassing phenomena. How this atmosphere has formed? Through outgassing. Remember, we discussed iron catastrophe, we discussed what? We discussed planetary differentiation, and the third step was outgassing. So when gases were released, you saw the formation of atmosphere. Fine. So we discussed that heavier gases are where? Near to the surface, and as you move up, what will happen? The lighter gases are something that are present. So density of atmosphere declines as we move from Earth's surface to up atmosphere. Fine. We started with the structure part first, and we discussed the troposphere. So we discussed the troposphere, and we discussed troposphere is what? It is a lowest layer, contains how much? Almost 75% of molecular mass, contains all your aerosol and water vapor. So all your aerosol and water vapor are present over here. We discussed almost all your weather phenomena happens where? All your weather phenomena happens in this layer. That part we have discussed. The third thing we discussed was it is a zone of turbulence. Because of weather phenomena, it is a zone of turbulence. And zone of turbulence is the reason why we discuss no jet or airplane moving in this region. No jet or airplane moving in this region. So it is a zone of turbulence also. We also discussed another part, that the troposphere is what? Troposphere, as you go up, what will happen to temperature? Temperature will decrease. As you go up in troposphere, temperature will decrease. Why temperature decrease? Why temperature will decrease? Because you are moving away from Earth. So Earth's heat is the source of heat. So as you are moving away from the Earth, temperature will decline in case of troposphere. Then we also discussed that troposphere is what? The troposphere is extending around how much? 18 kilometers at the equator and around 8 kilometers at the poles. No, we have written 18 kilometers yesterday. It is around 18 kilometers at the equator and 8 kilometers around the poles. So it is 18 kilometers over equator and 8 kilometers over the poles. So that part we have covered with regard to troposphere. So this we have discussed, made diagram like this, and we discussed this part is 18 kilometers and this part is 8 kilometers. So this is poles and this is equator. We discussed why this is happening, because air here is what? Air expansion here is more, because equator is more heated, receives more sunlight, so more heated. When more heated, air expansion here will be more. And we discuss here what will happen? Air expansion will be less. Air expansion will be less. So this is where poles are there. Fine. So air expansion more and air expansion less. Fine. So these part we have covered with regard to troposphere. Fine. This layer is also showing a phenomena which is called as a temperature inversion phenomenon. So you'll find this phenomena also in troposphere, which is called as a temperature inversion phenomena. So troposphere is also showing this phenomena called as a temperature inversion phenomena. What is this temperature inversion phenomena? Normally we discuss what? This is a normal condition. This is a normal condition in troposphere. As you go up, what will happen? Temperature will decline. But if opposite starts to happen, if opposite thing starts to happen, as you go up, temperature also start increasing, then this phenomena is referred as what? Then this phenomena is referred as a temperature inversion phenomena. Clear? So normally we discuss as you go up in troposphere, what will happen? Temperature will decline. But if opposite starts to happen, as you go up, if temperature start increasing, then it is going to be called as which phenomena? Temperature inversion phenomena. Generally these phenomena are being seen during the time of winters. So temperature inversion phenomena generally you find will be seen during the time of winter. Fine. So why during the time of winter you will see temperature inversion phenomena occurring in this region? Occurring in troposphere, why you will see temperature inversion phenomena? What happens? What happens? No. Happens as we discussed, in the winter earth will not receive what? Earth will not receive much of sunlight. When it will not receive much of sunlight, and also you know that daytime is what? Length of the day reduces in winter and length of the night increases in the winter. That is okay there. So when earth will not receive much of sunlight and also you will see more of night time, what will happen because of that? You will see earth will cool down. When earth will cool down, what will happen to the air? What will happen to the air that is in contact with the earth? It will also cool down. Clear? What will happen to the air in contact with the earth? It will also cool down. Fine? As what is happening in the winter? Earth is not receiving much of sunlight. When earth is not receiving much of sunlight, earth will cool down. When earth cools down, what will happen to air? Air in contact with earth will also cool down. But the air which is not in contact with earth remains what? Remains warm. Air that is not in contact with the earth remains warm. Air that is in contact with the earth cools down, but air that is not in contact with the earth remains warm. So as you go up, what is happening? This is a colder layer, this is a warmer layer, because it is not cooling down, it is not in contact with the earth. Clear? So it remains warm, while this remains, this becomes nothing but okay, what? This becomes a colder layer. So as you are moving from here to here, what is happening? Temperature will increase because you are moving from cold to warm region. So temperature will increase. So this happens, this phenomena is referred as what? This phenomena is referred as a temperature inversion phenomena. So as you go up, if temperatures start increasing, this phenomena is referred as what? Temperature inversion phenomena. So sometimes you may observe this phenomena also in troposphere, which is referred as a temperature inversion phenomena. Fine. Now, normally, as we discussed, normal condition is what? Normal condition is as you go up, temperature will decline. This phenomenon generally seen during winter, but there are other cases also. We'll discuss in detail temperature inversion later, but for now, just remember that generally it is being seen in which condition? Generally, it is being seen in a winter conditions. Clear? But there are different places also where you can see temperature inversion phenomena, and further division of or types of temperature inversion is also there. As we discuss more climatology, we will cover the detailed temperature inversion part. Fine. So this part, as we discussed, normally as you go up, temperature will decline. Generally, the rate of decline is around 6.5 degrees Celsius per kilometer. Clear? So as we are going up, how much temperature will decline? 6.5 degrees Celsius per kilometer. Let's say if at the Earth's surface temperature is around 40 degrees Celsius, when you move 1 kilometer above, temperature will decline by how much? By 6.5 degrees Celsius, that is okay. Clear? So in troposphere, generally temperature declines by this particular rate, that is 6.5 degrees Celsius per kilometer, and this rate is referred as what? This rate of decline is referred as a normal lapse rate, or also referred as an environmental lapse rate. So this rate of decline is referred as a normal lapse rate or environmental lapse rate. Fine. So as we discussed, generally if you go up in troposphere, temperature is going to decline. At what rate it is going to decline? Around 6.5 degrees Celsius per kilometer. This rate is called as what? This rate is called as a normal lapse rate or environmental lapse rate. Fine. So these are phenomena that you are observing in what? These are the phenomena you are observing in a troposphere. So it is a lowest layer, as we discussed. Lowest layer means all the heavier gases are going to be there. So it contains how much mass? 75% of molecular mass and almost all your aerosol and water vapor. This is okay present. Almost all your weather phenomena takes place in this region. That's why zone of turbulence. As you go up, temperature will decline. The rate at which temperature is going to decline is 6.5 degrees Celsius per kilometer, and this decline in temperature is called as what? Normal lapse rate or environmental lapse rate. Fine. Its extension is around 18 km and at the equator and around 8 km where at the poles. And this is referred as what? This is referred as a temperature inversion phenomenon. Fine. Now the second part is your stratosphere. Stratosphere. Second layer is your stratosphere. Now remember this layer which is acting as a boundary line, between troposphere and stratosphere. So this part is your stratosphere while this part is troposphere. The layer that is acting as a boundary line between troposphere and stratosphere is referred as tropopause. So it is referred as tropopause. Fine. And what is the extension of stratosphere? It extends from around 18 km to around 50 km at equator and around 8 km to around 50 km at poles. Fine. This is the extension of stratosphere. At equator it is extending around 18 km to 50 km and at poles it is extending around 8 km to around 50 kilometers. Fine. Second, what you see here is what? What you see here is as you go up in this layer, what will happen to temperature? As you go up in this layer, what will happen to temperature? Temperature will start increasing. Fine. So what you see is in stratosphere as you go up, temperature is what? Temperature is increasing. So it is exactly happening opposite of whom? Exactly happening opposite of troposphere. In troposphere we are saying as you go up temperature will decline, but here what is happening? As you go up temperature is something that is okay increasing. Why this is happening? Why do you see temperature increasing in stratosphere? Why do you see temperature increasing in stratosphere?
Because there is no much atmosphere.
There is no much atmosphere. We discussed why the temperature is decreasing in troposphere. As you go up, why temperature is decreasing in troposphere?
It is away from the land.
Because you are moving away from the Earth. Earth is a source of heat. Now stratosphere, when you are moving up in a stratosphere, you are moving further away from Earth. When you are moving further away from the Earth, what will happen? Further decline in temperature should happen. But here what we are seeing is what? Temperature is increasing. Because closer to the Earth, you will have more temperature. As you go up, we are saying you are moving away from the Earth, which is a source of heat. So when you are moving away from Earth, temperature should decline. But here what we are saying is temperature is increasing. Why this phenomena is happening? Why this phenomena is happening? This phenomena is happening due to a lot of chemical activity in this region. Chemical activity in this region. So What type of chemical activity? It is chemical activity is happening due to presence of a layer in this region which is called as a ozone layer. So as you go up in case of stratosphere, temperature is increasing. Why temperature is increasing? Temperature is increasing due to lot of chemical activity taking place in this region, and this chemical activity is due to presence of which layer? It is the presence of a ozone layer which is there in the stratosphere. This chemical activity is taking place due to the presence of what? Presence of an ozone layer which is there in what? Which is there in the case of stratosphere. Fine. Fine. So now remember this layer as a troposphere and this layer as what? Stratosphere. Fine. Where will you will have more temperature, here or here? Where you will have more temperature? In stratosphere you will have more temperature. Why? Because here we are saying as you go up what will happen? Temperature is declining. So let's say temperature reaches to around minus 60 degrees Celsius over here. As you are moving up, temperature reaches to around minus 60, minus 70 around tropopause. In this region, temperature is around minus 60, minus 70 degrees Celsius. That is okay what you are going to find at a tropopause. Now, in this layer we are saying temperature is increasing. So temperature will increase to what? Minus 50, minus 40, minus 30. You'll see increase in temperature, that is okay happening. So here in stratosphere temperature will increase. Fine. So what will happen to air? As we discussed here what is happening, since air is in contact with the earth, air is being heated. When heated air goes up, what will happen? When heated air goes up, what will happen? If condensation happens, you will see what? You will see decline in temperature as air is going up, decline in temperature. So what will happen? Condensation will happen over here. Clear? Now that's why this becomes a, as we discussed here, minus 60 degrees Celsius is there. Here you will see minus 30, minus 20 degrees Celsius temperature is there. So here, which layer is more colder? This layer or this layer? Troposphere is more colder. Anything that is more colder is going to be what? Anything more colder will form which type of pressure? High pressure. Anything that is okay warmer is going to be formed which type of pressure? Low pressure. So we discuss anything heated expands, low pressure. Anything cools down, what will happen? Contract, high pressure. So that's why here you see high pressure, here you see nothing but okay, low pressure, that is okay there. Clear? So because of which high pressure means what? You are compressing things. Okay, high pressure means you are compressing things. Low pressure means what? You are expanding things. Okay, that is okay there. Yeah. So because of this air will not move into what? This air will not move into stratosphere. Why this air will not move into stratosphere? Why this air will not move into stratosphere? Because expansion only happens when? Air will expand only when? When there is a low pressure. Air will expand when? When there is a low pressure. Fine. But here, when high pressure is there, then what will happen? From this layer to this layer, air will not expand. When air will not expand, that's why all your weather activity takes place where? All your weather phenomena takes place in this region only. It doesn't extend to stratosphere. Why? Because as we discussed, it doesn't extend to stratosphere as it is a zone of what? It is here high pressure is there, here low pressure is there. So for air to expand, what is required? Low pressure is required. Since here high pressure is there, that's why air will not expand into this particular layer. When air will not expand into this particular layer, all your weather phenomena is going to happen in a troposphere. It will not happen in a stratospheric region. So that's why stratosphere is not a zone of turbulence. It is not a zone of turbulence. So we discussed troposphere is a zone of turbulence. Stratosphere is not a zone of turbulence. That's why ideal for whom? Ideal for flying of jet and aeroplane. Ideal for flying of jet and aeroplane. So it is a zone of, it is not a zone of turbulence. As a result, ideal for flying of jet and airplane. Fine. So why this is happening? Because air will not expand from here to here. Air will not expand. As a result, all your weather phenomena is restricted much in this region. It is not happening in this particular region. So that's why it is ideal for flying of jet and airplane. Clear? Now, as we discussed, it contains which layer? Stratosphere contains which layer? Ozone layer. Ozone layer protects you from which radiation? Ultraviolet radiations. Yes, it protects you from ultraviolet radiations of sun. It protects you from ultraviolet radiations of sun. So it is present in ozone, it contains ozone layer, and ozone layer protect you from ultraviolet radiations. Fine. Now what type of chemical activity takes place in this particular reactions? Now there is a ozone layer. Ozone means what? Ozone means O3. Ozone means what? Ozone means O3. 3 oxygen atoms are going to combine. Fine. Now, if you remember, we talked about which type of bonding? We talked about something called covalent bonds. Remember, we discussed electrovalent bond and covalent bond. Electrovalent bond means one will lose atom and one will gain the one will lose the electron and another will gain the electron. That type of bonding is called as what? Electrovalent bonding. And in covalent bonding, what is happening? Sharing of electrons happens. Clear? So, how many electrons oxygen has in outermost orbit? It has the atomic number of 4. It has an atomic number of 8. So we discussed first orbit contains how many electrons? 2 electrons. The second orbit contains how many electrons? 6 electrons. So it has how many electrons in the outermost orbit? 6 electrons, that is okay, having in the outermost orbit. Fine. So we discussed when an atom is stable. When an atom is stable, when it has how many electron in outermost orbit? 8 electron in outermost orbit. It has how many electron in outermost orbit? Only 6 electrons. So that's why it is not stable. It is going to react. It is going to react. So that's why when you see two oxygen atom, like this, so they shares what? They shares their 2 electrons with each other. They share their 2 electrons with each other. So when they share 2 electrons, what will happen? It has how many electrons now? 1, 2, 3, 4, 5, 6, 7, 8. So its octet is complete. And it has how many electrons? 1, 2, 3, 4, 5, 6, 7, 8. So they share 2 electrons, and this sharing of 2 electrons is double bonding between oxygen atom. This is called as a O2. So O2 is what? O2 is a stable one. Clear? Because both oxygen atom octet is what? Complete. But what happens when ozone layer is formed? O3 is formed. When O3 is formed, octet is not complete. Why it is not complete? So we discussed one oxygen atom. It has how many electrons? 6 electrons in the outermost orbit. We take another oxygen atom. It has how many electrons in the outermost orbit? 6 electrons in the outermost orbit. We'll take another oxygen atom. It has how many electrons in the outermost orbit? 6 electrons in what? Outermost orbit. Fine. Now what this middle one will do? Middle one will share the electron with both oxygen atoms. Okay. So one electron with this oxygen, one electron with nothing but okay this oxygen. It will share. And what will happen over here? They will share this electron. They will share nothing but okay this electron. Clear? Now how much? Middle one has how much electron now? 1, 2, 3, 4, 5, 6, 7, 8. So you see octet is what? Octet is complete of middle one. But how many electrons this have? 7 only. So how much okay this have is okay 7 only. 1, 2, 3, 4, 5, 6, 7. So it has how many electrons? 7 electrons. It has how many electrons? 1, 2, 3, 4, 5, 6, 7. So it has how many electrons? 7 electrons. So that's why O3 is not stable. Why it is not stable? It is not stable because its octet is not complete. Clear? It is highly reactive. Ozone layer, ozone is highly reactive. This O3 is highly reactive compound. Clear? So when it is reactive, it wants to come in which state? It wants to come in a stable state. Why two oxygen atom reacts? They want to come in which state? They want to come in a stable state, that is okay there. So O3 is highly reactive. Why it is reactive? Because it wants to come in which type of state? Stable state. Clear? So what happens here is, in stratosphere, O3, in the presence of which radiation? Ultraviolet radiations, breakdowns into which? Breakdowns into O2 plus O. Clear? Because O3 is unstable, we discussed O2 is what? Stable one. So that's why this O3 will breaks down into what? O2 plus O, and this also releases lot of heat or energy. This is responsible for what? This is responsible for what? This is responsible for increase in what? Temperature. We discussed what is happening. Why, as you go up in a stratosphere, temperature is increasing. This temperature is increasing because of what? Because of heat that is being released because of these reactions that is taking place. So chemical activity. What chemical activity is taking place? O3 in the presence of which radiation? Ultraviolet radiation breaks down into what? Breaks down into O2 plus O. When it breaks down into O2 plus O, it releases heat or energy. This heat or energy is responsible for what? Increase in temperature. Fine? Any doubt? Now, what happens again is what? O2 plus O, again in the presence of UV radiation. Again in the presence of UV radiation, combines to form what? Combines to form O3. O2 plus O, again in presence of UV radiation, combines to form what? O3. So there is a continuous destruction and formation of ozone layer taking place. There is a continuous destruction and there is a continuous formation of ozone layer taking place. This chemical activity is taking place, because of which you see heat is released, and this is responsible for what? Increase in temperature as you go up in a troposphere. What if only this phenomena takes place and this phenomena will not take place? Then what will happen? If O3 start to degrade into O2 plus O, but O2 plus O don't combine to form O3, then what will happen? Then what will happen? Because both reactions are taking place. If only first one takes place, second one do not takes place, then what will happen? Then it is called as what? It is called as a ozone depletion. Ozone layer is depleting. So you have heard about term ozone depletion. Ozone layer is thinning. Ozone hole. Ozone hole means what? That the layer has gone. Hole has been created in this particular layer. This was layer. A hole has been created in this particular layer. So there is no ozone that is present over there. Why this is happening? This is happening only because one of the reaction is taking place, other is not taking place. Clear? So normally we discuss what is happening. Both destruction and formation takes place. Why destruction happens? Because O3 is unstable. It tries to achieve a stable state and in the presence of UV radiation. But in the presence of UV radiation, they also combines to form what? They also combines to form O3. But if this do not takes place, if this reaction do not takes place, then only what will happen? Destruction will happen. This destruction will lead to what? Thinning of ozone layer. Ozone layer will deplete over a period of time. This process is referred as a ozone depletion or ozone hole formation. Fine. So that's why we are we are trying to protect which layer? We are trying to protect the ozone layer, because ozone layer protects us from which rays? Ultraviolet rays. If ultraviolet rays reaches to the earth, what will happen? What will happen? It can, as we discussed, UV rays have a high, remember, we discussed first class cosmic microwave background, we discussed X-rays, ultraviolet rays, we discussed gamma rays. These have a high frequency, they have a high energy. When they have a high energy, what will happen? They can penetrate inside your body. So UV rays can cause skin cancer, other problems if it reaches to the earth. Fine? So that's why ozone layer is very important, because it protects us from which layer? From which thing? It protects us from the ultraviolet rays coming from the sun. Fine? Any doubt regarding this particular thing? So O3 divided into O2 plus O and O2 plus O divided into O3. Now, generally, why this formation will not take place? Why this this formation will not take place because of ozone depleting substances. There are certain substances which depletes the ozone, and we call them as what? We call them as a ozone depleting substances. So there are certain substances which depletes the ozone. For example, this single, okay, we discussed O2 plus O which is being formed. O2 is a stable one, but O is not a stable one because it has how many electrons in the outermost orbit? 6 electrons in the outermost orbit. So this O reacts with whom? This O reacts with the chlorine. This O reacts with the chlorine and forms, okay, what will happen? ClO. This O reacts with whom? Chlorine to form ClO. When this O is not available, then what will happen? When this O is not available, O2 plus O will not combine to form what? O3. Clear? For O2 plus O2, for O3 to form, this single O need to be available. But if single O reacts with the chlorine, then it is not available to form, okay, what? To form this combination process. And that's when, okay, you see only destruction will happen, formation will not happen. Clear? So these substances which depletes the ozone like chlorine are present in certain compounds like chlorofluorocarbon CFCs, or you have hydrochlorofluorocarbon HCs. Now we have shifted to now these compounds HFC and HFO because, okay, they are less ozone depleting. That's why we have shifted to nothing but, okay, HFC and HFO now. We are phasing out these compounds. Where you are using CFC and HCFC, they are used in refrigeration, they are used in cooling processes. That is in ACs, refrigeration, they are used in cooling process, okay, that is okay there. But these releases lot of what? Lot of nothing but, okay, chlorine. When chlorine reacts with oxygen, then what will happen? The free O is not available to combine to form what? O3. And when this formation do not happen, only destruction will happen. We call it as what? We call it as a ozone depletion and ozone hole. Fine. So in environment, you will be studying about these compounds. Okay. So you have an environment section also. In environment section, you will be studying about CFC, HCFC, the HFC, HFO. So these compounds you are going to study in case of environment section. And there is
the full form of HFO.
HFO is hydrofluoroolefin. OLEFIN. Olefin. Fine. So what happens is, okay, what CFC is having high ozone depletion. It depletes ozone, and it is also a global warming gas. High global warming causes huge global warming. That's why you have replaced CFC with whom? HCFC, hydrochlorofluorocarbon. You have replaced this with HCFC. HCFC has less ozone depletion, but it also have a very high global warming potential, which is causing climate change. It also has a very high global warming potential. That's why you have shifted towards which one? HFC. HFC has what? HFC has a less ozone depletion also, and less global warming potential also, that is okay there. Clear? But from HFC also now you are shifting to what? You are shifting to nothing but, okay, HFO, which have a almost no global warming potential, that is okay there. Clear? So that's why you are shifting now from CFC to SFC to HCFC to HFO. So that's why in environment you will be also studying about a protocol called as a Montreal Protocol. Montreal Protocol. This protocol has been framed to protect which layer? This protocol has been framed to protect which layer? Ozone layer. And it is, okay, dealing with which type of substances? It is dealing with the ozone depleting substances. So under this protocol only we are not using what? World over countries are not using now CFC or HCFC. They have shifted either to HFC or now shifting towards HFO. So why we are phasing out? We are phasing out these two. These because of which protocol? Montreal. So all these details we will be studying in environment. What is Montreal Protocol? What these are, okay, ozone depleting substances, global warming gases, all these will be studying in the environment section. Okay. So remember that when there is only formation, when there is only destruction of ozone happens, no formation of ozone happen, then what will happen? Thinning of ozone layer. When ozone layer will become thin, it is called as what? It is called as a ozone depletion, or formation of ozone hole can happen. Fine. So this phenomena also you are seeing where? This phenomena also you are seeing in the case of the stratosphere. So stratosphere is what? Stratosphere, as you go up, temperature will increase. Why temperature will increase? Due to chemical action, chemical activity. It is a zone of what? It is a zone of turbulence. It is ideal for flying of Zn. It is not a zone of turbulence. That's why it is ideal for flying of jet and airplane. It contains ozone layer which protects us from which radiation? UV radiation. So these are important points that you have to keep in mind with regard to stratosphere. Fine. Now the layer, this particular layer, which is acting as a boundary between stratosphere and mesosphere. So as we discussed, after troposphere what lies? Stratosphere. After stratosphere what lies? Mesosphere. So this layer which is acting as a boundary between stratosphere and mesosphere is called as what? It is called as a stratopause. It is called as a stratopause. So this layer is called as what? Tropopause. This layer is called as a stratopause. Fine. Next layer that you have is a mesosphere.
The previous slide, one minute.
This one? Or
Yeah, this one.
next layer that you have is a mesosphere. So now, what structure we are getting? So this is 8 kilometer, 18 kilometer. This is what? This is 50 kilometer, and this is going to extend till when? Till around 80 kilometer. It is going to extend till around 80 kilometer. So this layer is troposphere, this layer is stratosphere, this layer is what? Mesosphere. This boundary is called as what? Stratopause. This boundary is called as what? Tropopause. And this boundary is going to be called as a mesopause. It is going to be called as a mesopause. Fine. So mesosphere extends from where? Around 50 to 80 kilometer. That is the extension of mesosphere. Second important thing, it is mainly consisting of lighter gases. Mainly consisting of lighter gases. As we discussed, as we are going up, the heavier gases will decline. So it is mainly consisting of which type of gases? Lighter gases. The third thing that you find is as you go up in this layer, temperature again starts to decline. As you go up in this layer, what will happen? Temperature again will starts to decline in which layer? In mesosphere. Why temperature again starts to decline? Why temperature again starts to decline? So here we are saying, as you go up, what is happening? Temperature declining. As you go up here, temperature is increasing. But here, as you go up, what is happening? Temperature again is declining. Why temperature again is declining? No chemical activity, and you are moving, okay, what? You are moving away from the earth. So that is the reason why in mesosphere, you'll see temperature is declining. Clear? So as we are going up, temperature is declining. That is a normal case. Why in stratosphere it is increasing? It is increasing due to chemical activity. but no such chemical activity takes place in a mesosphere. That's why temperature will decline. Clear? Now, temperature around mesopause. Temperature around mesopause is very low. Temperature around mesopause is very low. Is very low. Somewhere around minus 80 to minus 100 degrees Celsius. Minus 80 to minus 100 degrees Celsius. Temperature declines, temperature becomes very low. Fine. The fourth layer that you have is what? We call it as an ionosphere or thermosphere. This layer is referred as an ionosphere or thermosphere. So beyond mesopause up to 400 km, you have extension of which layer? Ionosphere or thermosphere. This is referred as ionosphere or thermosphere. And above this, what is happening? Exosphere. Above this, what is happening? Exosphere. So extend from where to where? Extend from around 80 km to 400 km. That is the extension of ionosphere. And why it is called as an ionosphere? It is called as an ionosphere because it contains electrically charged particles. Electrically charged particles, which are referred as ions. Electrically charged particles which are referred as ions. So it contains electrically charged particles which are referred as ions. That's why it is referred as what? It is referred as ionosphere. Right? What is ions? Remember we discussed at atomic, just now we discussed sodium. Sodium will having 11 atomic number. Sodium will have 11 atomic number. So we discussed first orbit will contain how many electron? 2 electron. The next orbit will contain how many electron? 8 electron. And so 2 plus 8, 10. Outermost orbit will contain how many electron? 1 electron. Total electron is 11. So 2 electron in the first orbit, 8 electron in the second orbit, 1 electron in the outermost orbit. We discussed atom is not stable till it have how many electron in outermost orbit? 8 electron in the outermost orbit. So that's why what the sodium will do is what? It will lose the electron. When it will lose this electron, then what will happen? It outermost orbit contains how many electron? 8 electron. When it loses this electron is not there, then what will happen? The next outermost orbit becomes what? Outermost orbit becomes now this, and this contains how many electron? 1, 2, 3, 4, 5, 6, 7, 8. So when sodium loses an electron, when sodium loses the electron, it becomes what? Na plus. It becomes Na plus, which is referred as what? Which is referred as a ions. Why? Because it is losing 1 electron. So it now have It now have 11 proton, but only 10 electron. So it will acquire It will acquire a positive charge, and this is called as what? This is called as a formation of ions. So ions is formed when atoms acquires either positive charge or negative charges, then it is going to be called as what? It is going to be called as ions. And this layer contains large amount of electrically charged particles which are referred as ions. Now why this layer contains large amount of electrically charged particles? Why this layer contains large amount of electrically charged particles? Why do you see more of ions formation in this layer? Why not in other layer? Why not in other layer? As we discussed, why electron is present over here in sodium? Why electron is present in the sodium? Because we discussed nucleus is which type of charge? Positively charged, and electrons are which type of charge? Negatively charged. So there will be, you know that unlike charges are going to what? Unlike charges are going to attract each other. Okay, so that's why there is an attraction force which is binding the electron around, okay, around the nucleus. So if you want to take out electron, what is required? If you want, already there is an attraction force between nucleus and electron. So this attractive force is there which is keeping the atom together. Now if you want to take out electron, then what will happen? You have to apply certain energy force, then only what will happen? You can overcome this attractive force and take out nothing but, okay, electron. Yeah? So from where this energy is coming? To remove the electron, to overcome this attractive force. From where the energy is going to come? From where the energy is going to come to overcome this attractive force and take out the electron? From where this energy will come? It will come from the sun. Okay, what is coming? Sun rays are coming, no? So it will come from what? Sun will, okay, provide the energy because of sun's energy, okay, rays or cosmic rays that are coming. You see these gases that are present, they get the energy. As a result, they loses the electron and becomes which type of particles? They becomes nothing but, okay, ions particle. Clear? So why you see more of ion formation in this particular layer? Because the rays that are coming from the sun contains, okay, what? Contains nothing but, okay, high energy. This energy is, okay, what? This energy is going to what? Going to be useful in overcoming this attraction forces, and as a result atom will lose the electron to attain what? To attain nothing but, okay, the octet, or to complete its octet, that is, okay, there. And that's why you see formation of what will happen? Ions will happen. Clear? So when charged particles are going to be present, what will happen? We'll see formation of what? Formation of ions. So what is ion? If question comes, what if you have to define ions? What is ions? Ions are nothing but, okay, the atom acquiring a charge, whether positive charge or negatively charged. And why atoms acquires a charge? Because it either accepts electron or it either loses electron. So that is the reason why atoms acquires a charge. So since this layer contains lot of charged particles, that's why it is referred as what? It is referred as a ionosphere. Any doubt regarding this part? The second important thing, this layer also contains, as the name indicate, here it is thermosphere. As the name indicate, here it is written as what? Thermosphere. Thermo means what? Temperature. Yes, okay, heat, temperature. So in this layer, as you go up, what will happen? In this layer, as you go up, what will happen? Again, the temperature will increase, and that's why it is also referred as what? It is also referred as a thermosphere. Clear? Again, why this is happening? Again, why this is happening? Why temperature is increasing? Again, due to chemical activity taking place in this particular region. So as you go up in ionosphere, temperature will increase. When temperature will increase, that's why it is also referred as what? It is also referred as a thermosphere. And again, why this temperature increase is happening? Due to the chemical activity in this particular layer. Fine. So ionosphere extends from where to where? From 80 to 400 km. Why it is called as ionosphere? Because it contains electrically charged particles which are referred as ions. As you go up in ionosphere, what will happen? Temperature will increase, and that's why it is referred as what? It is referred as a thermosphere also. Fine. Now, there are two terms you have to keep in mind. One is called as a solar flares and another is called as a solar wind. There are two terms. If you remember when we discussed the evolution of solar system, we covered sun consists of various layers like core, convective zone, radiative zone, photosphere. We discussed the corona, outer part of the sun. We discussed is called as what? Corona, and it is visible only during what? In the eclipses period. So those things we have covered. So there are two terms when you are seeing solar flares and solar wind. Solar winds are charged particles. Charged particles which are emitted from sun's corona. Which are emitted from sun's corona. Which are emitted from sun's corona. It is emitted regularly. It is emitted regularly. This is called as a solar wind. It is a charged particles. Charged particles means what? Electron, proton, neutron. Okay, you have okay. These are the charged particles. So when charged particles are emitted from sun's corona regularly, then it is going to be called as what? It is going to be called as a solar winds. Fine. There is a term also called as solar flares. Solar flare is not emitted regularly. It is sudden outburst. Sudden outburst of electromagnetic radiations and high energy particles. Generally happens during the time of any turbulence in magnetic field. When any turbulence happens in a magnetic field, you will see these are okay. What? These are generated. Solar flares are something that are generated. Whenever there is a turbulence in whose magnetic field? Sun's magnetic field, then you will see these solar flares are something that are generated. Fine. So the two terms you have to keep in mind. One is called as what? Solar flares, and another is called as a solar wind. Clear? So these solar flares or these charged particles are reaching to where? These charged particles are emitted from the sun and are reaching to the earth. But earth is not allowing these charged particles to come what? Earth is not allowing these charged particles to come onto the surface. Why it is not coming onto the surface? Because of magnetic fields of earth. Yes, okay. This earth is not allowing these charged particles to come onto the surface. Why it doesn't come onto the surface? It doesn't come onto the surface because of Earth's magnetic field. So Earth also has a magnetic field. So it is not coming onto the surface because of what? Because of Earth's magnetic field. Earth's magnetic field. So these charged particles are the reason. Energy is okay. What? Energy is provided to outer. This is Earth. This is Earth atmosphere. Assume this is okay, ionosphere. This part is okay, ionosphere. Now because of Earth's magnetic field, what will happen? When charged particles are coming in this region, they are not allowed to enter into this particular region of Earth's surface. So Earth's magnetic field ensure that they do not reach to nothing but okay, Earth's surface. But they provide sufficient energy to what? They provide sufficient energy for ionization. Ionization in the upper atmosphere. They provide sufficient energy for ionization in upper atmosphere. Fine. Now what if this solar wind or solar flare reaches to Earth's surface? What will happen then? Currently we are saying Earth's magnetic field is protecting us from what? Protecting us from these charged particles, that is solar flares and solar wind, which are emitted from the sun. What if they reaches to the Earth's surface?
Temperature on the earth will drastically increase.
Temperature on the earth will increase. Any other thing? What will other thing happens? Damages to
agriculture or whatever.
Agriculture. Any other thing? Any other thing that you will find? The first major thing that you see is okay. What? The first major thing that you see is it can damage satellites. Generally in low Earth orbit, you are putting satellites where? In the low Earth orbit in this region, so it can damage satellites. It can affect the satellite movement and etc. That is okay there. That problem will arise. Second thing, it will affect communication also. It will affect communication also. Communication also will be impacted. Why communication also will be impacted? Because you have this particular what? You have this particular Earth which is in this shape, and this is where ionosphere are there. So ionosphere contain which type of particle? Charged particle. These charged particles are something that are present where? In the ionosphere. These charged particles are something that are present in ionosphere. Now what happens is, okay, let's say you are at this part of the earth, you want to communicate with person that is okay on this part of earth. Clear? You want to communicate with a person which is lying on this particular part of the earth. So what will happen is, okay, radio signals are sent like this, they are refracted back by whom? They are refracted back by the ionosphere. They are refracted back by the ionosphere, which is coming to nothing but, okay, this particular person's. Clear? So any type of radio communication, mobile communication, radio wave communication happens through what? Happens through nothing but, okay, ionosphere. Fine? It happens through ionosphere. So it can disrupt communication. It can disrupt communication, radio communication, other communication. It can also disrupt your what? The electrical power. Electrical power. You know that electrical power. Power is what? Electricity is what? Flow of whom? Flow of electrons. So any charged particle will come. What will happen? You will see attraction, repulsion, all those particular things will happen. Flow of electrons will get disturbed. Electricity, okay, problems and other problems may arise. Okay, electricity problems and other problems may arise because of what? Because of nothing but, okay, solar flares and solar wind. Clear? Any doubt regarding this particular thing? So these are the problems you may get. What? These are the problems you may get because of solar flares and solar wind. Fine? Any doubt regarding this particular thing? So recently an outrage has happened where power outrage in Spain. In Spain, you see the whole country lost the power, and initially, okay, what? That's why this concept of solar flare and solar wind was again in use. Whether this was caused, this power outrage has been caused due to solar flare or solar wind, or due to some other reason power outrage was there. So that's why this was, okay, what? This was much in use, because if it comes to the earth, then it can cause nothing but, okay, power outrage. It can cause electricity problems and other problems which can generate due to solar flares and solar wind. Fine? Any doubt regarding this part? So we discussed ionosphere is what? Ionosphere extends from where to where? From 80 to 400 kilometers. Contains what? Contains electrically charged particle. That's why it is referred as what? Ions. As you go up in ionosphere, what is happening? Temperature will increase. This also contains what? This also contains ions, and this ions is responsible for which type of communication? These ions are responsible for which type of communication? Radio communication. These ions are responsible for which type of communication? Radio communication. Fine. This region will also see what? This region will also see something called aurora phenomena. This region will also see something called aurora phenomena. Okay. What is aurora?
The light, the
Yeah.
green.
It is a rolling light. Yes, it is a light. Aurora is basically a rolling light. Rolling light that appears in Earth's atmosphere. That appears in Earth's atmosphere. So you'll also see aurora phenomena in this layer. Aurora is what? It is a rolling light that appears in case of Earth's atmosphere. Fine. It is seen both in northern hemisphere also and southern hemisphere also. Clear? Generally, these auroras are being seen near to the poles. These auroras are seen near to the poles. Clear? So generally in higher latitude countries, generally in Sweden, generally you will find in Norway, those countries that rise near to the poles, there you will see what? There you will see these type of auroras. Clear? Now why these are appearing in high latitude region? We are seeing these are seen near to the poles in high latitude region. Why these are appearing in a high latitude region? Because as we discussed, these are what? These when sun's charged particles are coming. When charged particles are coming, solar flares, okay, and solar wind, charged particles are something that are coming. These charged particles are deflected towards what? Deflected towards the poles by Earth's magnetic field. These charged particles are deflected towards pole by Earth's magnetic field, and this is the reason why you see auroras. Okay, this is the reason why you see auroras near to the pole region. Why auroras are observed near to the pole region? Because the charged particle that is coming, they are deflected towards pole by whom? By Earth's magnetic field, And that's why you'll observe what? You'll observe auroras in where? In the polar region or in high altitude region. Fine, any doubt regarding this one? So if question comes, okay, what is the reason why you see auroras more in case of, okay, higher latitude? You see auroras more in higher latitude because it is deflected towards whom? Deflected towards the poles by whom? By Earth's magnetic field. Fine. So that's why in higher latitude like Sweden, Norway, you see auroras are being observed. Clear? And these auroras are divided into two parts called as auroras borealis and aurora australis. These are referred as auroras borealis and auroras australis depending upon where it is occurring. Where if it is occurring in northern hemisphere or it is occurring in the southern hemisphere. So if it is occurring in the northern hemisphere and it is occurring in the southern hemisphere, we call it as a aurora borealis and aurora australis. Fine. Fine. So what you have to keep in mind is what? What you have to keep in mind is that ionosphere extends from where to where? 80 to 400 kilometer. Why it is called as ionosphere? Because a lot of points are something that are present. Second thing, as you go up, temperature will increase. That's why it is called as a thermosphere also. Here, ions are making possible which type of communication? Radio communication. So that's why radio communication happens through ionosphere. Auroras are what? Auroras are seen. It is a rolling light. It is a light that appears in the atmosphere and it is generally seen near to the pole. Why it is generally seen near to the pole? Because of Earth's magnetic field. Earth's magnetic field direct the charged particle or deflect the charged particle towards the pole. That is why they are being seen near to the polar region. And aurora borealis and aurora australis, these are two kind of auroras that we have. Fine. The last layer that you have is what? The last layer that you have is a exosphere. Exosphere. So outside of 400 kilometer and beyond, 400 kilometer and beyond, it is called as what? It is called as a exosphere. 400 kilometer and beyond, it is referred as what? Exosphere. These are generally consisting of light gases and charged particles, such as hydrogen, helium. Lighter gases like hydrogen, heliums might be present in the exosphere. Clear? Generally, above 2000 kilometer, 3000 kilometer in this particular layer, because we discussed it extend from 400 kilometer and beyond. Generally, beyond 2000 kilometer, 3000 kilometer, you will only find charged particles like electrons and protons in these particular layers. So beyond the 2000 kilometer or 3000 kilometer, you will only find the charged particle like electrons and protons that are present. Fine. Now there are two reasons in exosphere. So we discussed this is exosphere beyond 400 kilometer. We are calling it as exosphere. So as we discussed beyond 2000, 3000, you are generally seeing it consisting of electron and proton. There are two reasons where you see high concentration of There are two reasons where you see high concentration of charged particles. Charged particles. High concentration of charged particles. So there are two reasons where you see high concentration of charged particle, and these two reasons are referred as what? These two reasons are referred as a Van Allen radiation belt. These are referred as Van Allen radiation belt. This was discovered by a scientist called Van Allen. That's why named as a Van Allen radiation belt. Okay, so in exosphere, you'll find two reasons where there is a huge concentration of what? There is a huge concentration of charged particle, and these two regions are called as what? These two regions are called as a Van Allen radiation belt. Fine. So now we are coming to concept of coming to the concept of temperature change. How temperature is changing as we are moving from one layer to other layer. That is okay there. So at the surface, okay, generally you are finding what? Generally you are finding let's say at the surface there is a 40 degree of Celsius of temperature. As we go up till 18 kilometer, you know that 18 kilometer is of tropospheric length. So as you go to tropospheric length, we discussed there is a what? Decline in temperature. Temperature declines up to how much? Temperature declines up to 60, minus 60. So temperature declines up to minus 60. This is how you are seeing temperature declining up to minus 60, minus 70 in case of troposphere, which is around 18 kilometer. We discussed, okay, that the extension of stratosphere is up to 50 kilometer. So this region is called as a tropopause region, where temperature is constant. So tropopause region, temperature is going to be constant. Then we discuss what will happen in the stratosphere. Now this is a region of stratosphere. So in stratosphere you will see increase in temperature. You will find an increase in temperature in case of stratospheric region. So you will find increase in temperature. It can increase up to minus 15, minus 20. Okay, so you can see an increase in temperature will happen up to this level. I'll just make it with different colors. So this is okay, stratospheric extension. This is nothing but okay, tropospheric extension, tropopause. Then you see this part is what? Stratopause. You here will find again an increase, constant temperature. Then what will happen? Till 80 kilometer, you'll have what? You'll have decline in temperature, and here you'll see around minus 100, minus 20. So you'll see a decline in temperature again till mesosphere. Then you will see what? An increase. Beyond this in thermosphere, you will see an increase in temperature. You will see an increase in temperature. So this is how the temperature variation happens. Okay, this is how temperature variation happens. So if question comes, explain different layers of atmosphere, you have to make such diagrams. Okay, so you have to make this diagram, that is temperature diagram, and already one diagram which we have made for layers. Which other diagram we have made? So this diagram. Okay, so one diagram that you have to make is this diagram explaining the what? Explaining the different layers. That is okay. Troposphere, stratosphere, mesosphere, ionosphere, and exosphere. One diagram this you have to make with extension, how much it is there, and one you have to make this particular diagram. That is how temperature variation is something that is okay happening. Fine. Done.
40 is, that is 50, sir.
Which one? This is a 50.
50.
This is 50. This is around 18 kilometer. You get troposphere is around 18 kilometer. So this is extended. This is okay kilometer. This is denoting the height kilometer part, and this is including the temperature part. This is your temperature part. Fine. Answer the question 2.
So that's
C. Give me your answer. B. Give your answer. What the first statement says? Thickness of troposphere at the equator is much greater than poles. Is it correct statement? Wrong statement? Wrong. Why? What is thickness? What is the height of troposphere at the equator? 18 kilometers. So it is more in like thick. It is more thick at the equator, and it is more thinner at where? Poles. At poles, how much it is there? 8 kilometers. So thickness is where? Thickness is more where? At the equator, it is more higher in height, that is 18 kilometers. And at the poles, how much it is high in height? 8 kilometers. So first statement is very much correct statement. Second, at the equator, heat is transported to greater height by strong convectional current. So we discussed at equator what will happen? Wind expands. Why wind expands? Because heat transfer. We discussed heat transfer. How heat transfer happens in a gaseous fluid? Remember, in solid we discussed heat transfer happens through what? Conduction In liquid and gases, heat transfer happens through a convection. So gases, okay, expand. Why? Because of nothing but okay, convection only, that is okay there. So both statement are what? Both statement are correct statements. So answer will be what? A. Answer will be A. That both statement 1 and statement 2 are correct. At the poles, what is happening? At the poles, heat is not there. So gases will not expand. When gases will not expand, what will happen? Height will be low at okay poles, and height will be more where? At the equator. Clear? Because the gases there is expanding because of heat. Clear? So both statements are something that are correct. Clear? Answer this one. A. Anyone else? A. Anyone else? Now what it is saying, atmosphere is heated more by incoming solar radiation than by terrestrial radiation. What is terrestrial radiation?
Earth's interior.
Whatever the Earth's interior, whatever the heat, that is emitted by the Earth is called as what? Terrestrial radiation. Whatever coming from the sun is called as what? Solar radiation. If you remember, we discussed okay which type of radiation is absorbed by the atmosphere. Which type of radiation is absorbed by the atmosphere? We discussed that incoming solar radiation, when solar radiation are coming, it is in the form of which wave? Short wave. It is in the form of which wave? Short wave. And short waves, atmosphere do not absorb which type of wave? Short wave. Which type of wave atmosphere absorb? Long wave. So atmosphere is heated by whom? Atmosphere is heated by terrestrial radiation. We discussed what is the source of heat. Just now we discussed as you grow up in troposphere, temperature declines. Why temperature is declining?
Because it is away from the Earth.
Because source of heat is what? Earth. Not source of heat is sun. If your source of heat is sun, then what will happen? You are moving closer to the sun, no? So temperature should increase. Atmospheric temperature should, as you go up, what is happening? You are coming closer to the sun, no? If atmosphere is heated by the sun, then what will happen? As you are moving closer to the sun, atmosphere should have what? No temperature. But we are saying atmosphere is okay, temperature is decreasing. Why atmosphere temperature is decreasing? Because source of heat is what? Source of heat is Earth, not the sun. Remember? That's why we discussed okay, the gamma rays, X-rays, ultraviolet, visible. We discuss infrared. So we discuss sun's rays are more coming in this form. Ultraviolet are absorbed by whom? Ozone layer, visible rays. So atmosphere doesn't absorb nothing but okay, visible rays. But when Earth radiate, Earth mainly radiate in which form? In the long wave, that is infrared radiations, which is something that is okay being absorbed by whom? Which is something that is okay being absorbed by the atmosphere. Clear? So atmosphere is not heated by incoming solar radiation. It is more heated by whom? More heated by the terrestrial radiation. Source of heat is always the Earth. Remember? Source of heat is always going to be Earth. Sun's rays are mainly coming in which form? Sun's rays are mainly coming in ultraviolet and visible form, which are short wave radiation. What are long wave radiation? We discussed in microwave, radio waves, okay? The infrared wave, these are what? These are long wave radiation. So when Earth radiate, Earth will radiate in which form? Earth radiate in a long wave form, and these long wave radiation are absorbed by whom? Absorbed by gases like carbon dioxide and other greenhouse gases. Okay, so these greenhouse gases absorb what? They absorb long wave radiation, not the short wave that is okay there, because incoming solar radiation is a short wave radiation. So that's why first is wrong, second is correct. So answer will be what?
C.
Answer will be C. Statement no.
No,
D.
so it is D.
Answer okay is B. Statement 1 is incorrect and statement 2 is what? Correct statement. So like this question has been asked in case of examination. So that's why I am emphasizing Earth. The source of okay heat is what? Source of heat is Earth. As you move away from the Earth, temperature will decline because atmosphere is heated by whom? Atmosphere is heated by the Earth's radiation. It is not much heated by the sun's radiation, because sun's radiation are short wave, atmosphere do not absorb the short wave, whatever atmosphere absorb is a long wave radiations. Fine. So this type of questions has been asked in case of examinations regarding troposphere, regarding atmosphere. Then you also have
Justification is important.
so you'll also find, okay, what you'll also find in 2025 the question has been asked on continental drift theory. Clear? So this year prelims question has been asked on continental drift theory. We have already discussed continental drift theory, so just go and find out today what is the question that has been asked regarding continental drift theory in this year examination, and try to nothing but okay attempt those particular part. Fine. So see, this question was in news. That's why they have asked, okay, this particular part. Which of the following lakes of the West Africa has become dry and turned into a desert? Yeah. So there was a news in the 2022 regarding lake becoming dry. That's why this question has been asked in case of examination. So here answer is what? Fabubin. Okay, Lake Fabubin was one of the small lakes that you find in Africa, which has become dry and turned into nothing but desert. So if at all any such news are also coming, you just keep in mind lake related, any lake which is disappearing. Remember RLC questions we have discussed last class, that RLC is what? Shrinking in size because of what? Human activities. So we discussed RLC is a lake. RLC last class we discussed, no? RLC was lake, and it is shrinking in size due to human activities. So any lake which is disappearing, shrinking in size, those type of questions becomes important in case of examinations. Fine. Yes, 40 active answer. So just now discuss solar flares and solar wind. No? What is solar flare and solar wind? If solar flare reaches the earth, which of the following are possible effect on earth?
So what are the options?
Option C.
Option C. So just now we discussed if solar flares will come, what will be impact? We discussed satellite will be what? Affected. So GPS is what? GPS is through satellite you are getting. So this is going to be impacted. Yes. Why tsunami are generated? We discussed it generated due to earthquake. We have discussed earthquake. Earthquake generates what? Tsunami. So tsunami is not generated because of what? Solar flares or solar wind. It is generated due to what? Earthquake. So second is not going to there. Power grid. We just now discussed electricity system. Power outage is going to be caused due to solar flares. So this third is going to be there. Auroras. We discussed why auroras are being formed because of charged particle emitted from the sun. So yes, solar flares, solar winds. when it can create nothing but okay auroras, that is okay there. Next, forest fires. Why forest fire takes place? Because of lightning. When lightning struck any okay what? When lightning struck any forest or trees and etc., it leads to nothing but okay forest fires. Or sometimes due to human failure, human act okay, like human are going for what? Human are going for cutting trees, timber activities and other activities. There, if the area is dry, you are okay using cigarettes and other things, smoking in this region, then it can catch fires and etc. So humans can also cause. So this is not caused due to what? This is not caused due to the solar flares and solar wind. Orbit of satellite can be disturbed. Yes, that can happen. Short wave radio communication. Yes, that will be disturbed. We discuss communication system will get disturbed. So except for 5, which is okay there, and 2, all are going to occur due to solar flares and solar wind. So option C, 5 and okay 2 are not there in option C. So answer will be nothing but okay option C. So like this questions can be asked in case of examination regarding solar flares, solar wind. Fine. Fine. So have a break and then we'll further continue. So we were discussing about the atmosphere structure. So we are done now with the atmospheric structure. Now we are coming to the composition aspect. So in the last class we discussed atmosphere consists of what? Consists of gases and aerosol. It consists of gases and aerosol, and gases can be divided into major gases and minor gases. Oxygen, nitrogen, major gases, rest are what? Rest are minor gases. Fine. Now, what is the usage of these gases? What is the usage of these gases that we need to understand? Or what is the usage of aerosol? Is they are playing any role? So what is the usage of gases or what is the usage of aerosol that we need to understand? Yeah? So,
Air particles.
huh?
Air also.
Aerosol means, okay, these are dust particles, other particles which are present in the case of air. Yeah? So you have, okay, two important part, that is, okay, gases as well as aerosol. Fine. Now gases are what? First is oxygen. What is the importance of oxygen? You know that without oxygen there will be no life, because there is no respiration going to take place. So oxygen is required for oxygen is required for respiration. Oxygen is also required for combustion. Without oxygen present, nothing will what? Nothing will burn. So what will happen? Oxygen is also required for combustion. Oxygen is also required for degradation. You know that bacteria etc. absorbs oxygen and degrade things. So oxygen is also required for biodegradation of organic matter. Fine. So you know that there are two terms we use. One is called as aerobic and another is called as anaerobic. Aerobic means something that happens in presence of oxygen. When it happens in the absence of oxygen, then it is going to be called as what? It is going to be called as anaerobic. So if it happens in the presence of oxygen, it is aerobic. If it is happening in the absence of oxygen, it is going to be called as anaerobic. Fine. So aerobic is what? Aerobic is presence of oxygen. So when bacteria act in the presence of oxygen and degrade things, when bacteria act in the presence of oxygen and degrade things, such things are called as what? Such things are called as aerobic. Such things are called as aerobic degradations. Yes, so oxygen is also required for what? Oxygen is also required for degradation. Without oxygen, there will not be any degradation. Yes. So this is the importance of oxygen. Oxygen is very important for supporting life. Oxygen is very important for combustion. Oxygen is very important for degradation. Without this, nothing will happen. Right? The second important aspect that you see is a nitrogen. What is the importance of nitrogen? Because it is another important material that you are finding. So nitrogen is considered as a building block of life. It is considered as what? Building block of life, and it provides inertness to atmosphere. It provides inertness to atmosphere. It is a building block of life and it provides inertness to atmosphere. This is important part you have to keep in mind. Why nitrogen is called as a building block of life? Building block of life because it is very important for formation of proteins. You know that without proteins what will happen? Cells growth, cells formation, all these things will not be happen. So nitrogen is considered the building block of life. It is very essential for whom? For the plants. Very essential for the plants. Plants can't survive without nitrogen. That's why you provide them which type of fertilizer? Nitrogen based fertilizer like urea. You provide them nitrogen based fertilizers like urea because it is very essential for anyone's growth. Without growth will not happen if there is not nitrogen. So nitrogen is considered as what? It is considered as the building block of life. Clear? It is inertness means because you know that oxygen is what? Oxygen is combustion, helping in combustion. So oxygen is okay causing what? Oxygen is causing very high temperature. It is causing very high temperature because combustion is something that is okay happening because of oxygen. So that nitrogen, greater amount of nitrogen provide what? Provide inertness to the atmosphere. It provides inertness to the atmosphere. That is okay. Another important role of nitrogen. Clear? So inertness means it retards combustion. It retards combustion. That is what the term inertness means. It retards combustion, thereby making Earth's atmosphere livable. Clear? So because of oxygen, we have a very high temperature. If nitrogen was not present in huge quantity, we discussed how much nitrogen is present. 78%. If this much nitrogen is not present in the environment, then Earth's temperature would be very huge. Earth's temperature will be very huge. So nitrogen helps in clear? Atmosphere. The third biggest one is your argon. Argon is around 0.93% in the atmosphere. So after nitrogen, after oxygen, the third most abundant gas is what? Third most abundant gas is a nitrogen, which is 0.93%. Argon is what? Argon is a noble gas. It is a noble gas, inert gas. Noble gas, inert gas. What the term inertness means? Inertness means it will not be reactive. So that's why noble gas, inert gas. It is called as an inert gas. Its octet is complete. Clear? So any gas which is called as a noble gas means its octet is complete. Octet is complete means it is stable. It is not going to react. Fine. So that's why the argon is 0.93% in the atmosphere and helps in inertness of atmosphere. Clear? The carbon dioxide is present how much? Carbon dioxide is present in 0.03%. It is present how much? It is present 0.03%. This much carbon dioxide is present in the atmosphere. Fine. Now, what is the essence of, or what is the importance of carbon dioxide? The first thing, you know that it is very essential for photosynthesis process. It is very essential for photosynthesis process. Without carbon dioxide, there will be no photosynthesis. What happens in a photosynthesis? Carbon dioxide combines with water to form what? Glucose. And in the process, release what? Release the oxygen. So this process takes place in the presence of sunlight or chlorophyll. So carbon dioxide is very essential to start which process? Photosynthesis process. If this is not there, then photosynthesis process will not take place. Clear? Any doubt regarding this particular thing? Now, carbon dioxide is also used as a fire extinguisher. It is also used as fire extinguisher. It is also used as a fire extinguisher. So you know that fire extinguisher are there. Whenever fire comes, okay, you use fire extinguisher to minimize the fire. So this contains which gases? It contains carbon dioxide as a gas. Why carbon dioxide acts as a fire extinguisher? How carbon dioxide acts as a fire extinguisher, or why it is acting as a fire extinguisher?
It reduces oxygen.
It reduces oxygen. How? Yes, it reduces oxygen because oxygen is required for burning, and as we discussed, unless and until you cut off the supply of oxygen, the fire will not douse. Fine. So how this happens? For example, in the movies and etc., you have seen that whenever any person catches fire, what happens? You put blanket on the person. Why you put blanket? To stop the access to the oxygen, because if everything is covered, then oxygen will not reach to the fire, and if it is not reaching, what will happen? The person will be nothing but safe. Similarly, when you are using CO2 has a higher molecular mass, O2. Oxygen has molecular mass of 32. CO2 is consisting of what? Carbon and oxygen. So it has an atomic mass of around 44. So this will be attracted. We discuss more heavier means what? More heavier gas means what? More heavier means more attraction by the earth. More heavier means what? More attraction by the earth. Remember, we discussed what is weight. Weight is nothing but mass into gravity. More mass, more will be nothing but weight. More will be the attraction by the earth. So as a result, when you put the carbon dioxide gas, carbon dioxide mounts a layer like this and push oxygen level. Push oxygen level. Now the person is not in contact with the oxygen. When person is not in contact with the oxygen, what will happen? The fire will get doused. Fine. So this is how the carbon dioxide is also being used as well. Carbon dioxide is also being used as a fire extinguisher. So that is importance of carbon dioxide. Another major importance of carbon dioxide is what? Act as a which type of gas? Greenhouse gas. We discussed carbon dioxide act as a which type of gas? Greenhouse gas. So just now we discussed that the solar radiation is coming in the form of short wave. The atmosphere is not absorbing this short wave. Rather, carbon dioxide and etc. are absorbing this type of radiation, long wave radiation. It is absorbing long wave radiation. Clear? So, what is an average temperature? What is an average temperature of Earth? The average temperature of Earth is somewhere around 15 degrees Celsius. Average atmospheric temperature of Earth is around 15 degrees Celsius. When we take poles and equator together, average temperature is going to be around what? 15 degrees Celsius. That is okay there. Clear? Now, how this temperature is being reached? Because this carbon dioxide which is present in the atmosphere is absorbing the heat. If this is not there, then what will happen? If this will not there, whatever the heat that Earth will radiate will not be absorbed by the atmosphere. Will not be absorbed, then what will happen? Then temperature will further decrease. And if temperature further decreases, it becomes what? Difficult for human to survive. You know that colder region, polar region, less survival. Hot region, you see nothing but okay, more humans are something that are surviving. So if temperature declines, then what will happen? If temperature declines, if CO2 is not there, then temperature will decline. If temperature will decline, what will happen? Difficult for humans to survive. Fine. So this is also helping in what? This was also helping in maintenance of heat balance. So carbon dioxide is also helping in what? Carbon dioxide is also helping in maintenance of heat balance. But now what we are doing is what? We discussed how much carbon concentration is present. It is present around 0.03%. This much is concentration of food. This much is concentration of carbon dioxide. They are written. So how much carbon dioxide is present? 0.03%. So now what we are doing is what? We are increasing this concentration. Of carbon dioxide. So carbon dioxide concentration, how it is being increased? By burning of food, by burning of fossil fuel, be it coal, be it what else you are burning, petrol, diesel, biomass, everything is releasing what? Everything is releasing nothing but okay, carbon dioxide. So what will happen to concentration of carbon dioxide? What will happen to concentration of carbon dioxide? When you are burning all these substances, what is being released? Carbon dioxide is being released. So what will happen? Concentration will increase. If concentration will increase, what will happen to heat absorption? Heat absorption will also increase because we discussed it is helping in maintenance of heat balance. So if concentration of CO2 is going to increase, heat absorption will also increase. If heat absorption increases, what will happen? Then this is what we are calling as global warming. So now we are saying that global warming is happening or climate change is happening. Why this is happening? It is happening because of excess concentration of carbon dioxide. Clear? So whatever the carbon dioxide that is present in the atmosphere is necessary. Why it is necessary? Because we discussed it is necessary for photosynthesis process. It is necessary for which process? Photosynthesis process. And as we discussed, it is also necessary for maintenance of heat balance. So whatever carbon dioxide is present already in the atmosphere is very necessary for photosynthesis process, for maintenance of heat balance. But whatever extra that humans are adding is problematic. Because it is increasing what? It is increasing the carbon dioxide level. And when it is increasing the carbon dioxide level, what will happen? You see global warming or greenhouse gas effect that you are finding. Clear? Any doubt regarding this one? So this is okay problem that you find with regard to what? With regard to carbon dioxide. Clear? So whatever present in atmosphere is not problematic, but whatever we are adding is a problematic one. Fine? That's why if you see again in environment, when you study environment, you will see that there is a target that we have kept, that global temperature should not cross more than 16.5 degrees Celsius. Means there should not be increase of more than what? 1.5 degrees Celsius. Global warming is happening, temperature is increasing, average temperature is, we discussed how much it was there, 15 degrees Celsius. Now this temperature is now increasing. That's what we are calling as what? That's what we are calling as a global warming. This temperature should not increase more than what? More than 16.5 degrees Celsius. This target we have kept under an agreement which is now referred as what? This is now referred as a Paris Agreement. This target we have kept under an agreement which is now referred as a Paris Agreement. If temperature increases more than 16.5 degrees Celsius, what will happen? What will happen? If temperature increases more than 16.5 degrees Celsius, what will happen? Then in that case ice will melt, whatever ice that is okay there on the earth's surface, that is going to melt, glacier will melt, catastrophic changes will be there, ocean circulation will be disturbed, the evaporation, condensation, precipitation, all these systems will get disturbed. So that's why we are trying to limit this, okay, what? Limit this increase in carbon dioxide and global warming to how much? To how much? To how much? To a sustainable level, so that temperature should not increase more than 16.5 degrees Celsius. Clear? So this important aspect you have to keep in mind. So we discussed what is the usefulness of oxygen. Oxygen, as we discussed, respiration will not happen, life will not be there, combustion will not happen, no degradation, no recycling of material will happen. Without nitrogen, what will happen? Nothing will grow, because nitrogen is essential for who? Nitrogen is essential for protein formation. We discussed it is called as a building block of life. Nitrogen is called as a building block of life. It retards what? It retards combustion, that is okay there. So provide inertness to atmosphere. It provides inertness to atmosphere. Fine. So nitrogen we are trying to, nitrogen we have in the atmosphere, oxygen we have in the atmosphere. These are major gases. Now what are the minor gases? Minor gases are argon. We discussed already, it is a noble gas, 0.93%. We have minor gases as carbon dioxide. How much is percentage of carbon dioxide? 0.03%. What is the usefulness of carbon dioxide? Photosynthesis process, used as a fire extinguisher, used for maintenance of heat balance. That is the purpose of carbon dioxide. And others like helium, neon also provides what? They are also present in small amount, and they provide inertness to atmosphere. Fine. There are two gases which are highly variable. There are two gases which are highly variable, which are ozone and water vapor. So these two are highly variable. They are also present in small amount but highly variable. As we discussed, ozone is present where? In the stratospheric layer. And sometimes, okay, you see ozone formation can also happen in a troposphere. Clear? Sometimes ozone formation can also happen in a troposphere. But tropospheric ozone is toxic in nature. If you inhale, what will happen? If you inhale tropospheric ozone, what will happen? As we discussed, O3 is more reactive. If it is more reactive, then what will happen? It binds with your hemoglobin, and your blood and cells will be deprived of oxygen. So that's why tropospheric ozone is problematic. But in stratosphere, when it is present, what will happen? It will protect us from which rays? From the UV rays. Okay, so stratospheric ozone is beneficial, tropospheric ozone is problematic. But in troposphere, ozone can be formed due to certain reactions. How it is formed? Due to smog process. We'll discuss later how smog is occurring and how tropospheric ozone are being formed. So that's why ozone is highly variable, water vapor is highly variable. You know that there are certain areas where more evaporation will be there, so more water vapor content. There are certain areas where less evaporation and hence less water vapor content. So these are highly variable gases. These are highly variable gases. Fine. So these are importance of gases. The third thing that you find is aerosol. Aerosol. So this is also present in case of what? In case of atmosphere. So what is the usage of aerosol? What is aerosol? It is a solid particles or liquid particles that are suspended in the air. Suspended in air. This is what we call as an aerosol. The solid or liquid particles that are suspended in the air are referred as what? Are referred as an aerosol. Yeah. So small, very small, minute particles. These are very small, minute particles. These are suspended in the small particles, minute particles, suspended in the air. What is the function of this aerosol? What is the function of this aerosol? They act as what? They act as a condensation nuclei. They act as a condensation nuclei. As a result, make it possible for rainfall to happen. So they act as which type of nuclei? They act as a condensation nuclei. That's why make it possible for rainfall to happen. For example, what is this condensation nuclei is all about? Let's say a glass of water, you take a glass of water, put a cold water in this glass, steel glass you take it and put a cold water in this glass. After a few seconds or 10 seconds, 20 seconds, 1 minute later, what will you find? What will you find? You will find a lot of droplets on the outside of the glass. You will see a lot of water droplets are something that are present outside of the glass. So how it is happening? How it is happening? How do you see the glass on the outer side will have a small droplets that is present? If you are putting something cold water in a steel glass, you have observed this phenomenon? Outside of glass you will see cold water. Okay, some droplets are going to be present. How this is happening? It is happening because air contains what? Air contains a water vapor. Air contains what? Air contains water vapor. When cold surface is there, what will happen? Condensation of this water vapor will start to condense around this particular cold thing. Clear? So this provides a surface. Water vapor will start to condense around this particular cold surface. Clear? So when we are saying clouds are formed or rainfall is happening, what is acting as a surface? What is acting as a surface for condensation? These dust particles are acting as what? Surface for condensation. Water vapor converts into water on these particular surface that is okay there. Clear? So for condensation to occur, you need a surface. You need a surface, and what is acting as a surface? These dust particles are acting as a surface. That's why they are referred as what? They are referred as a condensation nuclei. Fine. So that is a function of food. That is a function of aerosol. So you see the dust particle, other particles that are present in the case of environment also have what? Also have certain roles to play. They also have a certain roles to play. They are not simply polluting the environment. They are playing certain role in the case of atmosphere. So that's why we say atmosphere is consisting of gases and aerosol. Each gas has its own importance. Like we discussed solid. Like we discussed, carbon dioxide has its own importance. Argon and helium, they are providing inertness to environment. We discussed nitrogen have its own importance. Oxygen has its own importance. Likewise, aerosol also have its own importance. Fine. So this is all about what? This is all about the structure and composition of atmosphere and what is the usefulness of atmosphere. Fine. Any doubt regarding this one? So without atmosphere, you don't see a life sustaining on Earth. Without atmosphere, you don't see what? Heat balance is going to be maintained. Without atmosphere, you will not see communication happens. radio communication, other communication. Without atmosphere, you don't see much of much of weather formation, precipitation, other things. So that all happening due to atmosphere, which is due to what? Gases present, or which is due to different layers that you have in the atmosphere. Fine? Any doubt regarding this part? Now we are coming to the next concept, which is the concept of latitude and longitude. Clear? So we have used this term latitude and longitude till now so many times. And like we discussed, auroras are found where? In the higher latitude we have written. So what is this latitude and what is nothing but this longitude? So basically both these latitude and longitude are the imaginary line. These are imaginary lines. Imaginary line means what? In reality, these lines are not existing. These are imaginary lines. Fine? Latitude and longitude are imaginary line. In reality, these lines are not existing. These lines are what? These lines are being drawn on a globe or on the earth. You are drawing this on a globe on a earth to study the location. To study the location of a place. So how to study the location of a place? For that reason you have drawn these lines, and these are imaginary lines. So naturally they are not present. These are human creation. Humans are creating these lines in order to study what? In order to study the location of a particular place. Fine? Now imagine, as we discussed, Earth is in which shape? Earth is in geoid shape, three-dimensional shape. Imagine this is how the front part and the back part. So this is how you are drawing a line, that is front part, this is front part, and since it is a solid sphere, it also have a back side also. So when you are drawing a line, the front side also you are drawing a line, and back side also you are drawing a line. Clear? So these lines, okay, are referred as what? These lines are referred as your latitude. One which you are connecting through poles, like this. If you are drawing a line, and these are going to be called as what? These are going to be called as what? Longitude. So one which connecting the poles are called as what? Are called as longitude. One which you are drawing in around the around the globe horizontally, then it is going to be called as a latitude. So it is a simple concept, that is what is longitude or what is latitude. But how we are defining this term? How we are defining this term? So latitude is defined as an angular distance of a place. Angular distance of a place from the center of Earth. Center of Earth. So it is an angular distance. Angular distance means what? Measured in a degree. Angular distance means what? Measured in degree. So it is an angular distance of a point, angular distance of a place from the center of the Earth. From the center of the Earth, measured in what? Measured in degree. Measured in degree. So angular distance of a place from the center of the Earth, measured in degree. This is how we are defining the term latitude. Fine? So assume this is a center of Earth. Assume this is a center of Earth. If any place you are taking over here on the Earth's surface, what angle it is going to make? No. If you are taking a place over here, then what? This is the center of Earth, and if you are taking any place over here, then what angle it is going to make? 0 degree. Yes, okay. It is on the same line, so it will make which degree? 0 degree. Now, as you are moving up, taking different places on the surface of Earth, what you see is, okay, angles are increasing. Angles are increasing, and poles are at which angle? 90 degrees. So that's why North Pole, South Pole, you are measuring as a 90 degrees. So it is an angular distance of a place on the surface of Earth. So this is on the surface of Earth, angular distance of a place on the surface of Earth, measured in what? Measured in degree. From there we are measuring from the center of the Earth. Clear? That's why this particular, this particular region or this particular latitude is called as 0 degree latitude, or we also call it as what? Equator. This is referred as a 0 degree latitude, or we also call it as what? Equator. So equator divides the earth into what? Two equal halves. Okay, equator divides the earth into two equal halves. It is called, that's why it is called as a northern hemisphere, and this is called as a southern hemisphere. Hemisphere means what? Half sphere. Okay, so hemisphere, this is okay what? Sphere. When you take half part, it is going to be called as what? Hemisphere. Clear? So that's why this is called as a southern hemisphere, this is called as nothing but okay, northern hemisphere. So the equator is, or 0 degree latitude is dividing the earth into two equal halves. And it is also known as what? It is also known as the biggest parallel. It is also known as biggest parallel. So latitude are also referred as what? Latitude are also referred as a parallel. They are also referred as a parallel, while longitude are referred as a meridians. They are referred as a meridians. Latitude are also referred as a term parallel. So which is the biggest parallel? Equator is nothing but okay, biggest parallel. Fine. As you are okay, what? As you are taking this parallel, this latitude, if you are taking this latitude, what will happen? It is parallel to what? Parallel to nothing but okay, equator, and it is making certain angles from what? It is making certain angles from nothing but okay, the earth center. That's why we call it as what? If making 23.5 degree, then we call it as which? We call it as a Tropic of Capricorn. And the same thing, if it is making 23.5 degree from okay here, then we call it as what? We call it as a Tropic of Cancer. So these are important parallel that you have to keep in mind. So equator, Tropic of Cancer, Tropic of Capricorn, these are important parallels. So out of this, which one is bigger in nature? Because as you go up, the sphere is what? The sphere is becoming smaller and smaller. So at the equator, you see broadest radius. As you are going up, what will happen? The length is decreasing. When length decreases, what will happen to parallel? Parallel will decrease. So that's why equator is called as what? Equator is called as the biggest parallel. Fine. If it is making an angle of what? It is making an angle of 66.5 degree. Then what will happen? It is called as an Arctic circle or Antarctic circle. So it is referred as an Arctic circle or Antarctic circle. Fine. So these five are considered as okay what? These five are considered main parallel. There are a lot of parallels as we discussed. You can draw as much parallel as you want. You can draw as much parallel as you want. 0 degree, 1 degree, 2 degree, 3 degree, 5 degree, 7 degree. You can draw as much parallel you want. But major parallel that we use for our geographical discussions are your equator, are your Tropic of Cancer and Tropic of Capricorn, and what you see is okay, Arctic circle and Antarctic circle. Fine. So what is a latitude? How we are going to define the term latitude? It is the angular distance of a place from the center of Earth measured in what? Measured in degree. Measured in degree. And equator is what? Equator is your biggest latitude or biggest parallel. And what will happen is okay, what? It divides the Earth into two parts, northern hemisphere and southern hemisphere. And what are the other important parallels? Tropic of Cancer, Tropic of Capricorn, Arctic and Antarctic circle. These are other important parallels. Fine. Now what is meridian now? Meridian is basically or longitude. So longitude is basically a thing connecting the North Pole and South Pole. So you are drawing like this. You are drawing like this. So it is connecting which two poles? It is connecting your North Pole and South Pole, and each longitude is referred as what? It is referred as a meridian. It is referred as a meridian. Fine. So as we discussed, for latitude we use the term parallel. For longitude we use the term what? We use the term meridian. Clear? So what is the definition for longitude? We say it is a series of semicircle connecting the North Pole and South Pole and passing through the equator. It is also referred as meridians. So it is a series of semicircle that is passing from what? Passing from pole to pole through equator, and such lines are referred as what? Such lines are referred as a meridian. Fine. So why semicircle? Because we discussed this is a sphere. Okay, this is a sphere. So when you take only from here to here, what will happen? Only half circle is okay being made. So that's why we are calling as a semicircle. If you take whole this thing, then it will become what? It becomes a circle. So when we are connecting from North Pole to the South Pole, only we are taking what? Half circle. So that's why we have written what? Series of semicircle. Clear? You know that a sphere makes how many degrees? Total how many degrees it is going to make? 360 degrees. So if it is a half circle, so what will happen is, if you are moving this side, like this is a 0 degree, which you are choosing this line, you just make it with different colors. So if you are choosing this as a 0 degree meridian, then if you are moving from 0 degree towards this side, or if you are moving from 0 degree towards this side, how much degree you are going to cover? 180 degree on this side and 180 degree on this side, because the sphere is how much? 360 degree. So if you are taking a center line, which is a 0 line, 0 degree longitude, from here if you are moving this particular side, if you are taking this longitude, this longitude, if you are moving towards this side, it is going to be called as a 180 degree maximum you can go, and here also 180 degree maximum you can go. So this part is called as what? East of meridian. This is called as what? West of prime meridian. This line that is a center line is referred as which type of meridian? Prime meridian. 0 degree meridian is referred as what? 0 degree meridian is referred as a prime meridian. Like equator is 0 degree, we refer 0 degree parallel as what? Equator. Like that 0 degree longitude is going to be taken as what? Taken as the prime meridian. Fine. So let's say instead of choosing this as a 0 degree line, instead of choosing this as a prime meridian, if I choose this as a prime meridian, what will happen? Instead of taking this as a 0 degree, if I take this as a prime meridian, what will happen? Even if I move this side, what will happen? I have to cover 180. Even if I move the other side, what will happen? Again I have to cover 180, that is okay there. So what will happen? There is no difference. Clear? Any meridian I can choose as a 0 degree meridian. If I choose any meridian, what will happen? Ultimately we have to cover entire sphere. An entire sphere will have how many degree? 360 degree. So either I can choose this as a meridian, either I can choose this as a meridian, either I can choose this as a meridian, that is okay there. Clear? Any doubt regarding this particular thing? Which is not there with the equator, because equator is what? 0 degree. It is a 0 degree latitude. In fact, you can't take this as equator because it is not going to divide Earth into what? 2 equal half. It is not going to divide Earth into 2 equal half and not going to make 0 degree from the center of the Earth, that is okay there. Clear? So equator you can't choose anyone else, but prime meridian you can choose anything, no? Because any meridian you take, you have to move 180 degree to the other side and 180 degree to the other side. So how we have chosen this prime meridian or 0 degree? So in 1884, a meeting was organized in Britain, in Royal Astronomical Observatory of Britain, to choose which meridian to be chosen as a reference line. To choose which meridians to be chosen as a reference line. So it was decided that the meridian that is passing through what? Meridian that is passing through Greenwich, that is near London. This Royal Astronomical Observatory lies in Greenwich and lies in London. So meridian which passes through this line or Greenwich line is going to be called as what? is going to be called as a prime meridian. So that is how we have chosen this prime meridian or 0 degree. So that is how we have chosen this as a prime meridian or 0 degree. So this important part you have to keep in mind. Fine. So how we are choosing this particular prime meridian? Because any meridian we can choose as a what? Reference line. So how we have chosen this as a reference line, as a prime meridian? There was a meeting that was organized in 1884 in Royal Astronomical Observatory, and it was decided that the meridian that is passing through Greenwich is going to be called as what? Is going to be called as a prime meridian. So this is going to be called as what? East of prime meridian. This is going to be called as what? West of prime meridian. Fine. So that's why you can decide a location. Let's say I have to find location of this place. So how will I decide a location of this place? I'll see how much degree it is making, what is the latitude location, and how much degree it is okay what? How much degree east of prime meridian this is okay there. So if I find this particular thing, then what will happen? I can find a location of a particular place. Clear? So that's why we are okay drawing these lines on a map, on a globe, to find a location of a place. Find in it out regarding this particular thing. So latitude and longitude. So a place location is being determined by whether it is in northern hemisphere or whether it is in southern hemisphere, or whether it is okay east of meridian or whether it is west of meridian, that is okay. Clear? So this is how we are trying to find out the location of a particular place. Clear? So what is the latitude definition? Latitude is a angular distance of a place measured from what? Measured from center of the earth. And longitude is what? It is a series of semicircle connecting what? Connecting the poles, north pole to south pole. And this is also referred as what? This is also referred as a meridian. And that is referred as what? That is latitude is referred as what? Parallels. Longitude is referred as what? Meridians. What are the important parallels? What are the important parallels? That is equator, Tropic of Cancer, Tropic of Capricorn, Arctic Circle and Antarctic Circle. What is important meridian? Prime meridian is important meridian. Fine. Now more detail regarding this latitude and longitude we'll take up in tomorrow's class. How this is okay affecting, because longitude is also determining your what? Longitude is also determining your times. Time. Like you have studied that something, if you see world time, it is mentioned in GMT. GMT is what? Greenwich Mean Time. So this is passing through Greenwich GMT. And when you see use IST, Indian Standard Time. So the longitude is also helping you to determine the time part. Fine. So we'll take up that in tomorrow's class. We'll discuss the test part first. Huh? Fine. So question number 1 says, consider the following statement: Atacama Desert, Gobi Desert, Namib Desert and Great Victorian Desert. These are the deserts that have been given. So Atacama Desert lies where? Atacama Desert lies where? It lies in Chile. Yes, so first pair is correctly matched. Atacama Desert lies in what? It lies in Chile, so first pair is correctly matched. Gobi lies in Mongolia, correct. China, Mongolia. We discussed Gobi lies over there. It is correct. Namib lies in where? Namib lies in where? Namibia. This is also correct. So remember we discussed this region. You find what here? Namib and Kalahari Desert. So we have discussed this desert over here, Namib Desert and Kalahari Desert. So even third pair is correctly matched. Great Victoria lies in USA. It is Australia. Yes. Okay. So Great Victoria lies in Australia, not in USA. In USA, which desert lies? In USA, which desert lies? Sonoran and Mojave Desert. In USA, which desert lies? Sonoran and Mojave Desert. These deserts we are discussing USA. So that's why fourth is wrong. So answer here will be what? 1, 2 and 3. Answer here will be 1, 2 and 3. So B will be the correct answer. Second, which of the following evidences supports the continental drift theory propounded by the Wegener? So what are the evidences given by the Wegener? What are the evidences we discussed given by the Wegener?
The matching of the continent.
Yes, physical affinity. Then we discuss rocks of same age, fossils. Then we discuss tillite deposit, glacial till deposit, tillite deposit we have discussed. So those are the evidences provided by whom? Provided by Wegeners. So here it is saying formation of continental glacier at the poles. Is it there? No, formation of continental glacier is not there at the pole. This is not given in the Wegener's theory. So first is wrong statement. Second, matching of continental ground boundary. Yes, jigsaw fit. We discuss physical affinity. We discuss this part of what? This part of Africa fits where? This part of Africa fits in North America and South America. So second part is correct. Jigsaw fit. Rocks of same age across the ocean. Yes, that is correct. We discuss rocks of same age. That is okay. Evidences provided by the Wegener. Fourth, similar marine fossils across the ocean. Wrong statement. Though it talks about fossils, but it doesn't talk about which type of fossils. Oceanic fossil or marine fossil. We discussed continental drift theory did not talk about what? Ocean itself. So it talks about fossils, but fossils present where? Fossils present on the land, not on the oceans. Continental drift theory did not talk about what? Did not talk about the oceans. So that's why fourth is a wrong statement. So only second and third are there. So answer will be what? Answer will be B. 2 and 3. Fine.
Did it talk about the ocean?
Continental drift theory. No, it didn't talk about ocean. No. We discussed ocean theories came from. We discussed earlier 1920s. 1920s what had happened? Wegener has given a theory. More discovery. We discussed what found inside the ocean did happen when? In 30s and 40s. When World War started happening, we discussed submarine technology, other technologies we developed, then we started to know about the ocean. So that's why the conventional current theory says what? Wherever rising limbs are there, what is going to be formed? Ridges. Wherever falling limbs are there, what is going to form? Trenches. So conventional current theory talks about oceans. You don't have, continental drift theory did not talk about oceans. That is one of problems. So here what is happening? Only second and third is correct. So answer will be B. Next, consider the following statement regarding sea floor spreading theory. The theory says that sea floor constantly renew itself. Correct or wrong? Correct or wrong? Very much correct statement. Very much correct statement. We discuss sea floor. Yes. Statement 1 is very much correct statement. It says sea floor constantly renew itself. We discuss what is sea floor spreading theory says. That sea floor is spreading, diverging. When diverging, what will happen? Volcanic eruption will happen. When volcanic eruption will happen, what will happen? New crusts are going to be formed. When volcanic eruption happens, new crusts are going to be formed. So yes, sea floor is new crusts are constantly forming. So it is renewing. Renew means what? Renew means what? New crusts are coming. So that's what, it is very much correct statement. Second, rocks from oceanic crust are more older than the continental rocks. Correct, wrong? Wrong statement. We discussed where the new crusts are being formed. Where the new crusts are being formed? In the oceans. In the oceans, new crusts are being formed. Not on the continent. We discussed this. As you move away from what? Ridges to trenches, what will happen? Age of the rocks will decline. Age of the rocks is going to, what will happen? Age of the rocks will increase because at the ridges you see new crusts are being formed. At the trenches you see older crusts are something that are there. So as you move from ridges to trenches, what will happen? Age of the rocks is going to increase. So that's why new crusts are going to form where? At the ocean. So oceanic rocks are what? Oceanic rocks are newer in age than the continental rocks. So second is wrong statement. Third, the age of continental crust increases from oceanic trench towards ridges. Wrong statement. We discussed just now that it is increasing from where? It is increasing from ridge towards trenches, not from trenches towards ridges. So second, thirds are wrong statement. First is correct. So here asking which of the following statement are incorrect is asking. Incorrect means what? Your second and third are incorrect. So incorrect question is not asking what is correct. It is asking what is incorrect. So second and third statement are incorrect. So answer will be what? Answer will be B. Answer will be what? Answer will be B over here. Don't mark it as A1 only because here it is incorrect that is being asked, not correct being asked. So read the statement what is being asked. Next, consider the following statement. Diverging plate boundaries do not lead to folding. Folding. Correct or a wrong statement? correct statement. We discussed folding occurs due to what? Compressive forces. So compression will not occur when plates are diverging. Compressive will only occur when plates are converging. So the diverging plate boundaries do not lead to folding. Yes, very much correct statement. Converging plate boundaries cannot lead to faulting. Now this is wrong statement. It can lead to faulting also. Converging plate boundaries can lead to faulting also, because faulting we discuss is what? Strike slip can also happen, dip slip can also happen. So this is okay, wrong statement. So first is correct, second is wrong statement. So answer here will be what? A1 only. Next, fifth one, which of the following condition leads to formation of volcanoes? Convergence between oceanic and continental plates. Where volcanoes are being formed? Where volcanoes are being formed? We discuss either it is formed at the diverging boundary or at the converging boundary, but in converging boundary it is only formed whenever oceanic collision are there or oceanic continent collision are there. When continent are there, it is not going to form because no subduction is happening in the continent collision. So convergence between oceanic and continental plate, yes, this can form volcanic eruption because subduction will happen. Convergence between two oceanic plate, yes, here also you can see. Convergence between two continental plate, no, third is wrong. Divergence between two oceanic plate, yes, that is correct. And divergence between two continental plate, now this is wrong. So answer will be what?
1, 2, 4.
Answer will be 1, 2, 4. A will be correct statement. Clear? Divergence between two continental plate, why it will not be formed over there? Why it will not be formed over there?
Because two plates are going away from each other.
So divergence you will have generally, you are creating space created means what? Volcanic eruption should happen. So why it is not going to form at what? Continent. When continental plate are diverging. We discuss what the seafloor spreading theory says. What the seafloor spreading theory says, that it is seafloor that is okay what? Diverging. It is ocean that is okay diverging, not the continent. Continent what is happening? Continent what is happening? We discuss, remember the first layer, what will be formed? Ethiopian highland. Then we discuss what happened. Further divergence will lead to what? Further divergence will lead to creation of rift valley. Further divergence will lead to linear sea creation. Further divergence will lead to what? Creation of what? Creation of oceans. So what you see is okay, divergence is okay happening in the oceans. Fine. Which of the following fact was not considered by those while discussing the concept of sea floor spreading? So sea floor spreading talks about what? We discuss what is the problem with the sea floor spreading.
It is not continuous.
It is not comprehensive like a plate tectonics theory. We discuss what is the problem with the sea floor spreading theory. It is not comprehensive theory like plate tectonics, but we discuss whatever sea floor has said is what? Is correct thing. Clear? So sea floor only talks about which concept? Sea floor only talks about sea. Doesn't talks about what? Continent. What is the problem with the continental drift theory? Only talking about continent, not talking about oceans. Like what is the sea floor spreading theory? Only talking about ocean, not talking about what? Continent. So if you remember, this point only, you can answer this one, which is C. What is the wrong state? Here it is, which is not discussed by the concept of sea floor spreading theory is what? Distribution of fossils in different continent, because sea floor cannot talks about what? Continent. So if you are remembering this point itself, that what sea floor is talking about, you can make this statement as what? Make this statement as a wrong statement, that sea floor spreading theory cannot talk about continent. Clear? So first statement says it talks about volcanic activity along ridges. Yes, it talks about wherever rising cliffs are there, new crusts are going to be formed, volcanic eruption are going to be there. Stripes of normal and reverse magnetic field. We discussed sea floor comes after what? Paleomagnetism theory. Remember? We discussed first theory came what? Continental drift theory. Second came what? Convectional current. The third comes as a paleomagnetism. So we discussed sea floor. What it is doing? Combines the information given from what? Convectional current theory and paleomagnetism theory. So paleomagnetism talked about polarity of rocks. So second is also talked in case of what? Second is also talked in sea floor spreading theory. Age of rocks from the ocean floor. Yes, we discussed which rocks Which rocks are newer in origin? Rocks that are formed in the ridges, and which are rocks are older in origin that are formed away from the ridges. Fine. So sea floor is not talking about what? It is not talking about continent. Fine. So answer here is C. Which of the following are the examples of volcanic island arc? Which of the following is an example of volcanic island arc? So Kuril, Aleutian, Mariana Island, Philippines Island. All examples of volcanic island arc. Fine. Where do you find Aleutian Island? Where you will find Aleutian Island, Mariana Island? Where you will find these islands? So read this whenever you are encountering these types. Just see the map. So here you are finding what? This is written as what? This is written as a Kuril Island. This is written as a Kuril Island. So we discussed Japan. From the Japan you see several lines are extending. These islands are extending between Russia and Japan. This island are called as what? This island is called a Kuril Island. Fine. Where do you see Mariana Island? Where you see Mariana Island? So here you will finding Mariana Island. Okay, above Australia you will find Mariana Island. We discussed this whole reason is what? Indonesia and other volcanic eruptions are something that are happening. So here Mariana Island you are finding. Clear? So whenever you are encountering these particular thing, you just refer the map. Aleutian Island, already we have discussed. Where do you see Aleutian Island? Aleutian Island, USA. Aleutian Island, where you are finding? So in the Northern America, so you can see this is the Northern America, USA part, and you see this islands are something that are extending in the Northern America. So this is Canada, this part is Alaska, part of USA, Northern America we discussed. So upper part is Canada, this lower part is what? USA, but this Alaska lies in USA. And this island that is extending is what called as a Aleutian Island. Fine. So these are the islands that you have to keep in mind. Clear? So we discussed this is how North America are there. So this is how you are finding North America. This part is what? Alaska. This part is Canada. This part is US. So this Alaska lies where in case of USA. And this is where Aleutian Island you are finding. Fine. So see this all in map. So here all are example of what? Volcanic island are. Next, deltas are depositional features of river. They are classified on the basis of their shape. What are the types of deltas formed by Indian river? So basically Indian rivers form cuspate type of deltas. Indian river forms cuspate type of deltas, or Indian rivers forms arcuate type. Indian rivers forms arcuate type. Most of Indian rivers form which type of deltas? Most of the Indian rivers forms are arcuate type. Most of the Indian rivers forms arcuate type of deltas. Okay, so answer will be C. Most of the Indian rivers forms arcuate type of deltas. Remember, we discussed types of deltas. We discussed Mississippi is an example of which type of deltas? Bird foot. Yes. So we discussed types of deltas earlier. We have discussed. So this was okay. Deltas we have discussed. We discussed this type of delta when it occurs. It is going to be called as what? Bird foot delta. And we discussed Mississippi rivers. Okay, is having the bird foot deltas, that is okay there. Indian rivers are more forming which type of deltas? Arcuate deltas. Remember, we discussed more deposition of sediments. That's why Sundarban delta we have discussed being formed at what? Being formed at the boundary. Remember, we discussed why west flowing rivers of India. We discussed west flowing rivers of India do not form much deltas. East flowing rivers of India forms what? More deltas. Remember that concept we have discussed? So we discussed the rivers that are flowing here, like Ganga, okay, Brahmaputra, they are forming more deltas because they are carrying more sediments. And west flowing rivers do not form much deltas. Why they do not form much deltas? Because first their flow is very small and they are flowing over Deccan rocks, which is harder rock. So they do not erode much. When they do not erode much, we discuss they forms what? They forms estuaries. Here they form deltas. Here they form what? Estuaries. So that concept we have discussed. So remember that it is arcuate. Next, transfer of mass of rocks and debris down the slope is a mass movement. Which of the following statement regarding mass movement is correct? First, mass movement are aided by gravity with no geomorphic agent like running water. Is it correct? Very much correct statement. So mass movement is what? Mass movement is when material rocks starts to flow under the influence of whom? Under the influence of gravity. So there is no involvement of other agent. If other agent are involved, then it is going to be called as what? Weathering, erosion. Those things are going to be called. It is not going to be called as a mass movement. Second, weathering is a prerequisite for mass movement. No, not necessary. Clear? It is not necessary for mass movement. We discussed even if earthquake occur, what will happen? Earthquake occur, what will happen? The rocks can displace under the influence of gravity. Remember landslide concept? We discussed, landslide can occur, so rocks from here can move downward under the influence of gravity with slight shaking and etc. So it's not necessary that weathering has to occur. Fine.
Weathering is also one of the reasons also.
It can be one of the reasons, but prerequisite. Prerequisite means without which it can't occur. Prerequisite means it is necessary condition, not necessary condition. It can loosen the rock. Weathering can loosen the rock, as a result rocks can come down. Clear? But it is not necessary that the mass movement will only occur due to what? Due to the weathering, because it is saying
this is only.
Prerequisite means what? Without which mass movement will not occur. That is what prerequisite means. Prerequisite means without which mass movement will not occur. So it is not a prerequisite condition. Clear? Fine. So if question has been given as weathering can trigger mass movement, this would have been correct. But it is saying weathering is a prerequisite, means essential condition without which mass movement can't occur. That's why it is it is a wrong statement. So answer here will be what? 1 only, 98. Second, which of the following rock is not likely to contain fossils? We discussed which rock do not contain fossils?
Granite.
Igneous rocks. What is the example of igneous rocks? Granite. Granite is an example of what? Igneous rocks. So obviously igneous rocks will not contain fossils. We discussed igneous rocks are formed due to what? Volcanic eruption. So granite is formed due to what? Granite is formed due to acidic lava coming out. So it will not be containing the fossils. So 10th B will be the answer. Which of the following are active volcanoes? So active currently are Etna and Vesuvius. Okay, these are active one. Mount Aconcagua and Mount Kilimanjaro are not active. Here, so Mount Etna and Mount Vesuvius. So we discussed Mediterranean region where you will see these type of volcanic eruptions. So these are active one. Fine.
Are they dormant, sir?
Which one?
The first time.
Kilimanjaro becomes extinct. It has not become extinct.
It's extinct.
Next, consider the following statement regarding earthquake. Intensity of earthquake is measured by Mercalli scale, correct? Yes. We discussed Richter scale measures the magnitude. Intensity is measured through Mercalli scale. Second, earthquake magnitude is the measurement of energy released. Yes. Earthquake magnitude is the measurement of energy released. Third, magnitude of an earthquake depends directly on amplitude of an earthquake waves. Yes, this is amplitude. This is amplitude. So magnitude depends upon amplitude aspect, that is there. Fine. Lastly, every integer on Richter scale show a 100 time increase in energy released. We discuss how much time? 32 into 32. Yes, okay. So we discuss 32 time increase in energy need to happen. So if Richter scale of 4 or Richter scale of 6 are there, so 32 into 32. If Richter scale of 4 and 5 are there, 32 times energy increase. So Fourth is wrong. First, second, third are correct statements. So answer will be A. 1, 2 and 3. Next, there is a mountain given and there is a types given. So Alp is which type? Alp is a folded mountain. Fold mountains. Alp fold mountain. Vosges is an example of block mountain. We have discussed Vosges is the best example of block mountain. Fusiyama is a volcanic mountain. And Vindhyan currently is a residual mountain. Vindhyan currently is a residual mountain. Vindhyan have lost its original height. So that's why it is okay now referred as residual mountain. Fine. So remember these. So answer here will be what? A3, B. Answer will be B. Okay. So A3, B1, C4 and D2. Next, which of the following are depositional landform formed by the glacier? So Silk or Kori, we discussed there is a erosional landform and there is a depositional landform. So Kori Lake is formed due to what? Erosion. When glaciers are eroding, then you see formation of what? Kori or the Silk Lake. Clear? So the first is okay, the erosional landform, not a depositional landform. But moraines and iskars are what? These are depositional landforms. Moraine and iskars are depositional landforms. So answer will be 2 and 3. So if you remember, we discussed erosional landforms of glaciers are what? What are the erosional landforms? We discussed Silk or Kori, pyramidical peak. We discussed berg shunt. We discussed U-shape, glacial trough, hanging valleys. Those are erosional landform. What are depositional landform? We discussed moraines, terminal moraines and etc. can be depositional landforms. We discussed glacial till. Remember, Crage and Tail, Roche Mountain. We discussed Drumlin and Easker. So those are what? Those are depositional landforms. So Easker is given, moraines are given. These are examples of what? These are examples of depositional landforms. Fine. The last is in the context of wind, dominant external agent in forming landform. Which of the following landform are created due to erosional activity of wind? So erosional activity of wind will create what? Jugan and mesas. Jugan and mesas are created due to what? Erosional activity. So remember, erosional activity of wind can create what? We discussed Jugan, Yarden, mesas, Bates. We discussed Inselberg or mushroom rock. We discussed these are formed due to what? These are formed due to erosional action of wind. And depositional action of wind, we discuss either you have what? Dunes or you have what? Loess. Dunes is further divided into what? Barkans and sea. So Barkans is an example of which type of deposition? Crescent shape. We discuss if rivers are depositing sand in a crescent shape, then it is going to be called as what? Barkan. If rivers are depositing sea high, low like this, then it is going to be called as what? Longitudinal sieve. So Barkan is an example of what? It is a depositional feature, not a erosional feature. Jugan and mesas, Bates are example of what? Erosional features. Fine. So answer here will be what? Only two. Only two are your answer. Clear? So this is all about what? This is all about the test part.
Again,
Huh?
I've said 4 minutes.
Alp is a fold mountain. Alp is a fold mountain. So Alp, you have Himalayas, Rockies and these, all these are examples of fold mountains. Fine. So thank you for today. Tomorrow we will discuss the means part. Anyone having any doubt?